Hello everyone, I'm Shine and you are watching Civil Engineering Tips channel. This is the fourth tutorial of Shear Wall Design in ETABS playlist. In this tutorial, we're going to discuss about the practical application of shear wall and the advantage of using shear wall. When we analyze and design a building, we check a various type of serviceability of that building. If we observe that building is failing for a specific serviceability check, then we try to correct that by increasing column size. Furthermore, if that building fails, we can use shear wall along the direction it is being failed. This is a very useful solution, and in this tutorial we will observe a building without shear wall and with shear wall. Then we will understand what actually happens when we use shear wall. Using shear wall is not a solution. You have to know how to place that shear wall in the building and you will get maximum benefit from that. Let's discuss about the first figure. Here we have placed the shear wall along the direction of seismic force on Y direction, and in this case we are getting higher resistance of force EY because stiffness is very high along this direction. But if we consider earthquake force along X direction, then we will get poor resistance of force EX because stiffness is very less along this direction. A shear wall is subjected to lateral force for either EX or EY, but not for both. It depends on position of shear wall and direction of lateral force. So whenever you are using a shear wall in the building, you have to think how you will place that shear wall and you will get the benefit. Shear walls are designed for in-plane bending only. It's considered that it provides resistance along longer direction, not in the shorter direction. We opened our ETABS software. Now we will open a G+9 storied building. For that we have to go to this open option. Then we will go to this G+9 folder, and here we have created two models. The building is same, but for the first model we used shear wall, and for the second model we didn't use any kind of shear wall in the building. We will observe a serviceability check for the both of the model, and we will differentiate between use of shear wall and without shear wall. First of all, we will open this folder without shear wall, and we will click on this G+9 storied ETABS file. Then we will click on this open option. This is our ETABS model, and if we go to the plan and choose any level, then we click on OK option, then we will see that there is only core shear wall around the lift, but we cannot see any kind of other shear wall in this building. Now let's go for run analysis. I'm clicking on this run analysis option, or you can press F5 button to run the model. I'm clicking on here. Okay, run analysis is complete. Now we will go to table option, then we will expand the analysis results, then we will expand joint output, then we will expand displacements, and we will click on this story maximum over average displacement. I am right clicking on this option and clicking on show table option. Now we will right click on this output case option, and we will choose a specific load combination to check the displacement of this building, and these four load combinations are responsible for displacement check. First of all, we will check for this D plus 0.5L plus 0.7 WX, and we got these four load combinations from BNBC 2020. I am clicking on this load combination and clicking on this blank area. Now we will right click on this maximum option and we will choose sort descending, then we will get the maximum value, and here it is 1.82. This is our particular Excel sheet to check the story displacement or show limitation or lateral displacement or horizontal displacement. So for this load combination, we got the value as 1.82. I'm typing here 1.82 and pressing enter. The next load combination is D plus 0.5L minus 0.7 WX. I'm right clicking on this output case option and we will choose the load combination as D plus 0.5L minus 0.7 WX, and we will click on the blank portion of this window. And similarly, we will right click here and choose sort descending, and here it is 2.3 as the maximum displacement for that particular load combination. So for that load combination, we got the displacement value as 2.3 and it is the maximum displacement. The next load combination is D plus 0.5L plus 0.7 WY. Now we will right click and we will choose this load combination. And here we will get the maximum value of displacement as 4.44. So here we are inputting as 4.44 and pressing enter. Our next load combination is D plus 0.5L minus 0.7 WY. Similarly, we can right click and choose this load combination and right click here and choose sort descending, and we are getting the value as 4.44. We got the similar value and we are inputting here 4.44 and pressing enter. Now we have to fill up this column and it is story height above ground. Now we close this window and right click and choose add or modify grids and go to modify or show story data, and we are getting the height of this building as 121 feet. So here we are inputting as 121 and pressing enter, and here we are getting the result. It is failing in the direction of Y, but along the X direction it is okay. Now we close this window and click on this cancel option, and we unlock this model and we click on OK. Now we will take the decision on which direction we need to place the shear wall, as it is failing along the direction of EY. So we have to use shear wall on this direction, but along EX direction it is okay because there are a lot of columns that are resisting the whole building against the earthquake force along X direction. But along Y direction it is not safe, and we have to correct that by using shear wall on these three locations on both sides of this building. I have already created that and we have saved that model in the same folder. For that we have to open that model. I'm clicking on this option and saving this model, and we will go to G+9 folder and we will open with shear wall folder, and I will click on this file and I will choose this open option. So this is our model, and we can see that we are using 6 number of shear walls on left side and right side of this building. And if we go to the plan and we choose any level and click on OK option, then we will see more clearly that we used 3 number of shear walls in these 3 locations, and the longer dimension of the shear wall along Y direction as it was failing for EY. On the right side of this building we see the similar case. We are using 3 number of shear walls along Y direction. So now we will check the story displacement in this model and we will differentiate these 2 models. For that we will click on this run analysis button. Okay, our run analysis is complete. Now we will go to this table option and we will expand analysis results. Then we will expand joint output, and then we will expand displacements, and we will right click on this option and choose show table option. And similarly we will right click here and we will choose those 4 particular load combinations, and that is here. The first load combination will be this one. I am choosing it and clicking on the blank and right clicking on maximum and clicking on sort descending option, and here the maximum displacement value is 1.31. So for this load combination we got the value as 1.31. Again we will right click on here and we will choose this D plus 0.5L minus 0.7 WX, and we will click on this blank and we will right click on here and choose sort descending option, and we will get the value as 1.63. So here we are inputting as 1.63 and pressing enter. Again, we're right clicking here and we'll choose the load combination as D plus 0.5L plus 0.7 WY. And we will right click here and choose sort descending, then we will get the maximum value and it is 2.85. We are inputting here as 2.85 and pressing enter. Again, we are right clicking here and we will choose the load combination as D plus 0.5L minus 0.7 WY. Then again we will right click here and choose sort descending option, then we will get the value as 2.85. For this load combination we are getting the value as 2.85. I am inputting here 2.85 and pressing enter. So we observe that along X direction the whole building is safe because the number of columns was enough to resist the earthquake load along X direction, but along Y direction it was little bit difficult to resist the earthquake force because the building was very narrow. There was not enough resistance or stiffness along Y direction, and we used 6 number of shear wall along Y direction and the displacement value decreases. So from this video we got the result that using shear wall is a solution to resist lateral force like earthquake or wind. It was a very useful and practical application of shear wall inside the building, and each structural design engineer should know about this fact. So this is all for today. Stay happy, stay safe. See you in the next tutorial.